see if anyone can hear me now. I can hear clicking. That's a good sound. Hi! Okay, everything seems to be working now, so hi everybody. My name is, well, if you can read my channel name, you know who the hell I am. This is just a normal stream. There is nothing wrong with this, at least I don't think there's anything wrong with this. I do expect that people, if you are looking at the stream, to at least look at the day of the stream. I should explain why there's nothing going wrong and that everything is normal, right? So let me restart. Yeah, so that should explain why there's nothing wrong, right? Everything is normal. Don't be unexpected by anything, okay? So our objective here today is to try and CAD a new Beta 75X reframe. So the Beta 75X HD, which is a drone from the good old days. Actually, it's not too old. So the Beta 75 HD is a drone from roughly the 2000 somethings. I have a 2S version of one just sitting around, but the frame has been cracked for a while, so I wanted to try and rehome it and reframe it. That means we've got to actually sit down and redesign and reframe everything, which is going to be interesting to deal with. So this is the design. I've already got sort of everything put together. Uh-oh, we got an error. Yes, I know my education license expires soon. No, I'm not going to do anything about it for the next couple of days at least until things happen. So let's okay, give me a sec to check with some things. Okay. So, okay, let's get started absolutely with the beginning. So, because I don't like the way this originally was designed, because I was just guessing at that point. So we're going to start with a new assembly, just make things easy. Let's go and save the assembly in Beta 75 HD. Okay, so we can reframe it. So first thing we're going to do is we're going to place all the equipment. So let's make sure that we've got them all. We need the battery, we need all of the things, and we also need the motors. Okay. Oh, failed open document. Oh, an image not yeah, so I accidentally included an image. That's fine. So 1, 2, 3, 4, 5. That means we accidentally didn't click the right thing. So we have the AIO, the CAD total. Here it is. Yep. Okay, so we have our electronics. We have to electronics space. We've got our camera. And we've got what appears to be a motor mouse. Good. So let's look at it from the front view. So this is Autodesk Inventor 2021. I don't use the newer version of Inventor because I am lazy and I hate having to reinstall Inventor every couple of rounds. That is one thing I will give to SolidWorks, is that I don't have to reinstall SolidWorks every year. Right? The other thing is, the only reason why I'm not using that is because, one, it is annoying sometimes to use SolidWorks, and two, because I don't have my license with SolidWorks right now. So that makes sense. Let's see how everyone's going. It says that live chat's currently not working. That can't be good, so let's really quickly check to see why live chat's not working. I'm not sure if anyone has typed anything yet. Okay. Gonna test and say hello. Alright, so the stream, so live chat is unavailable. Okay, that's interesting. Let's try and get that back up. So really quickly we're gonna go to OBS and fix that so I can see at least what people are talking about. Docs, YouTube chat. Chat is disabled for the stream. Why is chat disabled for the stream? Uh-oh. What's going on here? What? Why is it Why is it? That can't be good. Okay. So, I guess the chat's not working for the stream, which is fine, right? We're gonna do our best here. So if anyone is chatting anything, just, you know, politely let me know. Somehow, through some sort of messages, and we'll go from there. Yeah, okay, so I don't know why YouTube chat's not working. If anyone has any questions, I will just periodically check it, just to make sure that everything is going fine. Alright, so let's get back to it. Let's get back to it. I hope if everyone likes the background music, by the way. Let's make sure that it's on loop. Cool. So, the fact that I don't know why it's doing that. Alright, anyway, so now we have all electronics plugged in, so let's think about a good layout. I'm thinking our objective is to try and get it as slim as possible, right? So that way it can be mounted into places. I want those motors upside down, so let's go ahead and do that real quick. If we rotate, oh, that's not in fact what we wanted to do. Okay, so that's why. So let's just free rotate it for now, so we kind of have it in the right position. We can actually fix the rest of it later in post, when we actually have an assembly to look at. So 2, 3, 4. Okay. So now we kind of have a generalization. So this is a slammed design. So for those who are unaware what a slammed design is, there are a couple of generational versions of slammed center whoops. Shendrone makes, of course, the most common one, which is the Shendrone. It's of course not showing up because of course it isn't. So what you do for slammed is you try and make sure that it gets as short as possible. So you don't really have these big giant ducts, right? There are disadvantages to this, mostly in that it requires the system to be a lot more complicated, right? There are also advantages to it, right? So we're going to try and take use of those advantages this time around. I really like that design actually, where it's kind of top down. So it's landing on the base design. That's a pretty good one. I think for now though, we're going to go with something similar to actually I don't know what we're going to go with. Let's think about that. So we want to sort of go with something that can So we need to be able to have a main piece that mounts all 4 components together, right? We also need to be able to mount the battery somewhere. Now the easy solution would be to mount the battery like this, right? Sort of like this. But that does make it very tall, right? So that does pose a challenge. What would be really nice is if we could do something like this. But that would make it too rear-ended, right? Because this is also going to make it way too wide, right? So we'd have to go up in propellers compared to what we normally would have. It basically means the only option we have is to do some sort of stack like this, right? Where it kind of looks like that, right? And this is, again, just rough for now. So let's push this up a little bit. So, oh, that's also a challenge. So the flight controllers, let me check the physical components to see if there's actually enough wire to go that far. Because that will be a challenge. Oh, I forgot I was going to do that. Oh, there's definitely enough wire to do that. So like to plug it in, say downish. Yeah, there's definitely enough wire to do that, so I think we should be good. For batteries. Oh, that's where the other big battery went. So that's where the other big battery went. Alright. So, that means the obvious and simple design, which is this, is a good idea. One thing I'd really like to do is put... no, we don't have space, so... Really, this is about the only thing we can do. Wait, there is something that we're missing? Where's the VTX? Where's the video transmitter at? The video transmitter is in fact not in the CAD, so that is a problem. So let's see if I've got a CAD of it. And if it's not there, we have to CAD that in first. So let's see if we've got a CAD of it. Huh. You know, I in fact do not have a CAD of it. So let's pull it up and see what we got. So, oh, we're also missing the little LED attachment in the back. Okay, so let's fix that first. Here we go. So there is the A01 VTX, which is exactly what we're using. It's stock, because I am lazy. We could upgrade it with another VTX, but for the moment, I'm too lazy to do that. So we're gonna think about where that goes as well. But first, let's find a schematic of it, so that we can sort of plug it together. That's the closest we've got. Oh, that's nice of it. They don't tell you any sort of dimensions in sketches, so that is a mild concern. Alright, let's think about this. So now we're in an interesting challenge. Okay, so let's at least see if it's anywhere. So let's at least look it up. Maybe we're lucky and it shows up. Oh yes, you guys have seen my bookmarks. Boba Fett, Anime, For All Mankind, Top Gear, and oh god, which one is this one anyway? Great, so there are no spaced dimensions for this. That makes things interesting, so we're gonna have to actually get the physical model and measure it. Now, if today wasn't today, I would simply pull it out on stream and pull out my calipers on stream and measure for you guys. However, because today is today, we will have to do some things off camera, just because things are things. Let's check this while we're doing that. We can check to see if anyone has opened up chat. Oh, I am the only one watching myself. Okay, that is big sad. Alright, so let's get a caliper, let's measure it. It is 28 millimeters by 16 millimeters. Okay, so let's CAD that up first real quick. So let's open up the CAD file, create a new file, make sure it's in that, and we need it to be called the correct thing, so it should be the A01 VTX. Okay, so let's draw the first 0, target lock. The first dimension is 28 millimeters. In between the middle of that, it's 17 millimeters. Is it 17 millimeters or 16? Let's verify that. It's in fact 16 millimeters. So, okay. In between the 2 points, we have is an 8 millimeter gap. So let's put 8 mil here. Okay, let's connect these two together. Perfect. So now everything should be nice and golden. Yep. So now all we gotta do now is just connect it. Oh, okay. It's not that simple. So 3 millimeters here and here. So 3. And that's to put I think an M1.5 screw through the whole thing. Oh, so why are these blue? So why are these blue? Oh, because this dimension's missing, so this should be 7. There we go. So now we can get a rough diameter estimate, height estimate. thickness of the PCB is roughly 1 millimeter. Oh, that's a really, really thin PCB. Nice. And thank you, Beta HD, for actually Beta FPV for actually trying to optimize their circuit boards a little bit. At least the ones that are power driving, which is exactly what they should be doing. Okay. So that goes right here. Oh, that makes things a lot tighter, because now we've got to play... Let's just make it that tighter. So like that would make sense. Right? Something like this. Okay, so that seems kind of reasonable. Huh. Alright, so let's think about this a little bit. What we need to do now is we need to make sure that... I mean, if we could do a... No, that would be too wide. So this would be the best option here. Could we invert the flight controller? We could, couldn't we? We could invert it so that way we access the computer from the top and the plugs from the top, so that way this makes more sense. So let's try that, I think. Let's verify first that we can do that, because it's designed to go this way, and it goes the other direction. The computer may not be as happy. So let's see if Beta FPV will, let's see if it'll accept that. So let's go to flight controller. This is their STM F411 board. This is going to be an interesting one. So, geometrically, okay, so this is going to be interesting. Alright, so... Let's think about this. So, we need to verify that, Okay, so let's think about this. So what we really want to do is we want to make sure that beta, because it's running beta flight, right? So we can check the FC page. Cool. So 12x. They've got flashback box. That's what we have. Okay, so it's on controller. So bottom front, we USB ports on the back. Okay, what we need to do is make sure that the drone understands that it's inverted. So can beta switch invert flight controller. So let's see, there's at least a tutorial for how to invert the flight controller. That's not what we want to do. How to mount your FC upside down. Just plug like I normally would. Turn the computer upside down. You manually configure it, so we can check that in the configuration tab. Nice. So that means let's grab Beta Flight, which is the basics, and let's plug the controller in because we have USB cables and USB cables can do that. So okay. So now we have Beta Flight open, right? We can plug in the flight controller and just see how things are going. Let's see if we can invert it. We're waiting a signal. Connect. Well, that's not good. Well, that is interesting. So there's no connection, which is a bad sign. Maybe it's just because this USB port is bad. No, it is just not connecting. That is what we call bad. So let's try again by plugging in a different USB port and see if it picks up. And then if not, we're going to have to use WinUSB to try to figure out what the fuck's going wrong. That has done nothing. So this is a driver issue. At least we think it is. So let's get the plug controller in. And then now let's run the driver tool to make sure that everything is working fine. So let's go to see if the driver tool, impulse RC driver fixer, which does work more times than I can count. It's saved my blood on those occasions. Fixing serial port driver. Oh great, now the device is not recognized. An error report, unexpected number of devices detected. That is what we call a bad. So let's disconnect. There we go. There is in fact a loose wire hitting the ground cable. Okay, so that's fine. So, forward, back, left, right. Okay, so let's invert it. So it must be like this. So this is it panicking, right? So configuration, we can now set the configuration to be inverted, hopefully. Full sensor alignment, here we go. So we need it to be, that's correct. So it should be 180. Let's see if that fixes things. Save and reboot. So forward. Center. Whoa, we are getting a big lag spike. Whoa, that's why. Back. Forward. Back. Left. Right. Reset Z axis. So it's not calibrated at all, which is fine. It's calibrated real quick just to make sure that it was correct. Forward. Back. Left. Right. Okay, so now we fixed that problem, which is good. So now we're in a good position. Let's go back to here, disconnect the flight controller so we don't have any issues. Sometimes you just love the fact that Windows 11 is weird. Okay, so yes, we can do it this way, which makes things a little bit easier. The one thing that is now the question is the battery, right? So where are we going to put this big, giant battery? You try and position it properly somewhere. Alright, so that's going to be complicated because we need to develop a single board to basically connect all these pieces together, which is going to be rough. And then once that's done, oh, this is going to be a rough one. Okay, so now that's the most logical place to put it because then we can up the camera a little bit. Yeah, because then the camera will fit there just fine. It's good enough, actually. I'm not too big of a fan of that. Because normally for a design like this, we want it to be up like here, and then either have a flat top or bottom, so you can put the battery on it. So the Beta 75 lands bottom side up. Most of my other drones though land with a battery on the top, and there is a stability calculation, right? So we can verify this is stable using someone's paper. Thank you, that guy. Battery on top or bottom, research paper. So this is there's a known research paper. Oh, that's not what I wanted. Ah, yes, thank you security for making sure nothing breaks. Let's refresh the page maybe? Okay, so let's think about this. Bottom mount FPV drone. There is a strip on this somewhere. I will have to look for it. Oh, here it is. This paper, this comes from paper somewhere. So it's all down to personal preference. Just don't fall for the pendulum. pendulum fallacy, right? So, so if the increases velocity stability, increases velocity stability. Well, it's a camera drone. I guess just based on a mounting pattern. Just based on a mounting pattern, we really don't have a oh, we really could, because we mount it like this. We can maybe set it up so that there's a top and bottom mount system. Yeah, let's try that. So, yeah, so now that it's sort of all in place-ish, we can do a top or bottom mount, and as long as we center this between the two, we can really be able to make that pick. Or we could, so that is a thing, we could make it do, actually a better idea, so let's do that instead. So let's make the battery sort of this way, because that's what it was, that's not the configuration it has on the system, but it does sort of help. So that'll make things better, I think. The one challenge right now with this design is that, yeah, we're gonna have an overlap, so it's gonna look a little bit like it's gonna look exactly like DJI drone, but you know that's gonna have to be the case. So let's get started, people. All right, one last check to make sure no one's murdered me. Okay, so I guess that basically solves most of it, right? Yeah, I think it's the best we got. The only challenge now is it's going to have to be overlap with the system, so we have to make sure the propellers don't strike the electronic space. That's going to be the big challenge with this layout. Maybe we set it on bottom, and we can lower the motors a lot. We can guarantee that. Looks like it. Yeah, so it's going to have to be this configuration with the battery on the bottom. Or we can just align it so that we can try to align it. No, it's not. The alignment's really not possible because these motors are way too far back. Okay. Now let's do some geometry, because now it's about time we start doing that. Lower 1, let's stand on APT. Let's sort of create it. So let's do our first. Okay, let's make sure it's at 45 and angle that away. Alright, okay, let's make sure that send this up perpendicular. So now it's an actual square. Okay, verify rotation is not going to kill anything. Good. Okay, so now all you need to do is just set the dimension. Okay, and this should be 30. Alright, let's overlap just to be sure. Yeah, that covers most of it. Yeah, that covers it perfectly. Alright. Okay, so let's do 3 pieces. So we've got a really complicated center body shell, which is going to suck, but we don't have a choice much in the matter. Let's hide this battery real quick because it's getting in the way. Transparent. So we're going to have a OBS is disconnected. Uh-oh. That's not good. My Wi-Fi go down? That's not good. Are we back? Are we back? I think we're back. Who is the robot workshop? Hello. Do I know this human being? Oh, vaccinated stuff. Man, OBS is just giving me shit right now. Oh my god. Maybe let's kill some RAM. What RAM can we cut right now? So what is killing our RAM? Nothing really. Well, Firefox is killing some RAM, so maybe that's it. Let's cut down the RAM on Firefox. Is OBS happy now? OBS Yuguchi? No, it's our Wi-Fi settings. So something's wrong with the Wi-Fi. Let's see if just disconnecting we could. Okay, we should now be back online. Good. So, hey. Awesome. Alright. Okay, so now we're back online, so let's get back to the CAD. So, now we've got sort of this layout and this first primary and secondary layout as well as a redesign. We can sort of just get started now. First things first, now that we know the body lower is, let's ground it. Where's ground? I am blind right now. There's grounded. Okay, so now it's centered. So everything in the world is going to be revolving around the center body frame. I'm thinking, so overarch? Yes, let's do an overarch design. So an overarch design is basically where, oh god, I'm gonna get so much crap for doing overarch. Let's cut it out first. So what we really need to do now is we need to first make sure that the center body is correct. So let's at least get those into position, right? So now let's use a regular center point rectangle. Center point rectangle, click. So roughly 20 millimeters. This is just rough right now. Just so that we can sort of figure out, because the camera is 19. So that's not enough. So it's got to be somewhere like 24 millimeters. Give us a 2 millimeter wide gap. And maybe we can back the camera. Yeah, we can back that camera up a lot. So that's about as far as we actually need that to go. It's going to be forward heavy. Can we maybe do a, no, because that camera's going to be in the way. Alright, so this is going to be rough, but, why are those here? What's center point rectangle? Oh, it's used to collect the center point. Okay, so now, no, so let's do one big 90 mil. Okay. So let's just draw two lines real quick. These lines are both incorrect right now, but that's fine. First thing we're going to do is we're going to set center points of both to each other. Cool. So let's set an angle between the two. So angle A and angle B. 104. Okay. So now let's also set its center to the position. Now we need to set these two equal. Okay. So that's not good, right? So if we draw a circle here with a reference of 43. No, let's parameterize that so we've got it on record. Parameters. So let's create a parameter for a numeric motor width and then propeller width. We know the propeller width is 43 millimeters according to the thing, so we should probably make that 44 just to make sure we don't have any. Let's make sure that's 44 so that way we don't have any chance of propeller strike. Although propeller strike is not going to, it's going to be pretty rare unless we're in a crash scenario, and if we're in a crash scenario everything's already gone to crap. Yes, hello Robo Workshop, yes I am designing a drone. You know, just everything is perfectly normal today. Uh, you know, it's just a normal day. Nothing is wrong. I hope that sort of helps. Okay. Um, just remember today's date. That should make complete sense as to why I look like this. Alright, so 44, and then the motor mount should be that. So let's really quickly go back to sketch. Oh, let's go to actually view. Tools, measure. We need to measure the diameter of that. So that is 14.45, so that means that our parameter should be around 15. View. You know, it'd be really nice, like, future Autodesk people, I don't know if y'all exist, but it'd be really nice to just have, like, parameters here, like, models here, and then parameters down here, like, right where this tab is. So that way I can just see the parameters as I go along, and I can manage them much more effectively. Anyway, prop width, okay. This is gonna be a tough one, right? Because now I've got to make sure. Okay, then maybe getting rid of the angle will help things better. We need to make these. We need to mirror these. Okay, that's gonna be interesting to deal with. All right, so let's stop playing around with this. Maybe, yeah, let's mirror it so that way we've got it. So 1, 2, 3, and let's mirror over the mirror line this one, apply, and done. So that means now, good, okay, so that's kind of good. I think that works the best. It is much bigger though, but I mean it's supposed to be much flatter too, so we've got that advantage coming along nicely. Okay, so that should make things a little bit interesting. Maybe we can take this down to 23. It gives us 1.5 millimeters each side. Yeah, I think that'll work. So that's a good dimension, right? Because that's about as far as we really want to push it. Okay, so I think we're now good actually, because now we can sort of do this. Let's set up parallel constraint from here to here, and that locks us in. So the only challenge that I have with this right now is look at the distance between A and B, right? So this is geometric, so that means that everything is equidistant. So if we look at this, there's a lot of empty space. There's a lot of space here to here too. So this is what we call bad. Butterfly? Yeah, we have to do butterfly. So butterfly design is the back is slightly smaller than the front. Yeah, we have to do butterfly. Okay, so let's do butterfly design. So this is wrong then. So let's get rid of all of this. So 1, 2, 3, 4, 5, 6. That is all wrong. Okay, so what we need to do now is we need to do butterfly design, which means we do a line here of, let's give a dimension of, let's do a normal dimension, draw a circle of prop width. Okay. And now we have to do some playing around. Okay, so in order to make sure that the dimensions are somewhat okay, we're going to set this to be non-dimensioned. Let's just set this to 1 right now. Actually, no, cancel. Let's make that a dimensionless circle. And let's set these two equal. So butterfly design is when everything is slightly misaligned. Like, so like here is, let's select the dimension. So here is like A, and then here is B, where it's just slightly forward backward, right? It is really annoying to deal with, butterfly designs. So maybe we set a line between the two and make this a stable dimension. No, it needs to be a stable dimension. So let's make an actual solid dimension. That's not what I fucking want to do. Alright. Alright. I'm with you. I'm with you, inventor. 50. Okay, so that gives us a nice... Why can't we change? Okay, so this... Okay, so now let's set this to be perpendicular to this. Gives us a point of reference, and then we can do something like this. So we can pull it really far forward. Or we can angle it a little bit far back like that. That means that we do have 50 millimeters. Okay, let's check one more thing. So we want to make sure the distance between the two is rational. This point to this point. So what distance is this? That's not what I wanted. Click, click. That's not what I wanted either. Can we set it equal to 50 and just see what that does? Yes, we can. That gives us this. So this is a butterfly design. It looks like a butterfly when you have it. So let's actually mirror it right now. We don't need this or this or that or that. So let's deselect those three. Now we just have these components, and now we mirror it over the line. Actually, really quickly, let's deselect this line. Otherwise, everything's going to break. No, so deselect that line. Okay, deselect these 2 points so that we don't have everything falling apart when we do this. Mirror line, click, apply, done. So now we have this, right? And you can see that it, with the propellers aligned the way they are, it's going to be slightly odd shaped, which is fine, right? Nothing wrong with a little bit of strangeness. That's not. Oh, that is what we wanted. That's not what we wanted. It's in fact giving it to us upside down. Okay. Okay. Let's get this all to be perpendicular to each other so that we've got those one record at least. Okay. Let's also sort everything real quick. So let's create a folder. Motors. Okay, nice motor folder. Let's create electronics folder as well. Let's put the battery there as well too. Okay. So is my face tracking still working? Yes, it is. So, I guess this is as best as we can do, right? Because we can do this, and it gives us a nice perfect sort of triangle, or we can do this, and it gives us the best we've got. I think that gives us the best we've got. Oh, there is one more thing, isn't there? Yeah, there's one more thing. We need this to be perpendicular to this, so we want this and this to be as close to the center of the line as possible, so it gives us a little bit of room to work with. So let's do this. Let's do that. Make sure they're. So it's not. So let's make sure that it is. So let's connect this to the center point here, which is right there. Good. That is correct. So let's make this. This is gonna break something. No, it's not. It's not. Okay, perfect. So this means that this is the optimal layout. So that is the optimal layout. Unless you want to shrink it even further, which we really can't because the battery's already in a bad position. Yeah, it's already too short for the battery. Maybe let's bring the battery to the top side now. Yeah, that's the only thing we can do now is bring the battery to the top side. So that does give us a little bit more wiggle room to put the camera forward. Well, actually, why do we do this? Where the camera's like, drag is going to be a nightmare with that. Yeah, this is going to be a nightmare with that, actually. It's not too bad of an idea, like if we do it like this. It's not too bad of an idea. It's not a good idea. In fact, it's an awful idea. Okay. Alright. Yeah, battery's gonna be a big issue because we need to figure out where this goes. I guess we stick to our original. Can we go to original config? Yeah, we can. So we can rotate the battery like this and put it back here-ish. Push the camera a little bit forward. So in a good position here. Let's realign the camera so it's in a good spot, like right there. I'm gonna put the battery right here. That does give us a lot of elbow grease to work with. That gives us a lot of elbow grease to work with. Okay, so that is good actually, I think. That's not a bad design concept. Let's think about this. Is there anything more we think we can do here before we just start going into direct CAD? Any dimensions, any specifications? Okay, so let's lock this down now. So this is what we want. So let's dimension these two, and this should lock everything into position. 55. Good. Okay. Drag profile is going to be weird as shit because yeah, drag profile on this is going to be weird. We have to invert this again, I think. Yeah, let's invert the controller again. Yeah, so let's put everything like this configuration. Good, so that gives us good positioning for this. It gives us good positioning for that. Oh, I see a problem already. There is no space between here and here for the flight controller wall to have any sort of dimension. So this needs to be closer to 60. Give us just enough elbow room to give us some wall space here. Let's verify that. So return to the main sketch. Yeah, okay. That is big. That is big. And the battery is leaning to the rear. Push the camera forward a little bit. Yeah, okay, that's the best we can do. So, fuck the camera having protection. We're just gonna do it like this. It also gives us a nice space to do that. Alright, so let's do that. That's actually not a bad idea. Okay, so let's do this. So, okay, so this gives us a good position here. So let's do that. Let's line this up. That's what I wanted. Let's line this up with the wall of this, and then gives us some. Actually, that gives us a pretty good design. The only catch is going to be here. There's going to be a lot of extra space. Right? Okay, so let's take a step back first. So we can. So what comes next is up to a human debate. We can either do it section by section, or we can do reference pieces. So let's do reference pieces. That makes things a little bit easy. No. Yeah, let's do reference pieces. So let's go to design. Where is it actually? Yeah, so there should be derived component. Create substitute derivatives. Yep. So let's. No, that's not what I wanted. Yep. So let's pattern it. So let's pattern the body lower. Okay, so that's not what we want. Oh god, how it copy. So just click body lower. Okay, so we need to make a body center. The new file name is body upper. Yep. We need to also do one for bumpers as well. So let's do a bumper. Let's unground that so we unground that so that it doesn't have any problems. Okay. We also do edit bumpers. So let's copy it again. Click body lower. Click next. We need bumper. Okay. Okay, so now we've got that 1, 2, 3. Right, it keeps grounding it so that it doesn't do anything stupid. Okay, we got bumper left. Okay, we need to rename this. Initial diagram. Okay. So, there are two ways of doing this. We can either make a general shape of what we want the drone to look like now in one big piece and then split it up. But that's going to be annoying to split up later. Or we can start doing section by section. So let's start with the section that's easiest, which are the bumpers, right? Oh god, everything is sort of messy right now. So let's fix that first by dragging the bumpers far away from everything so we can sort of look at it by itself. Cool. So that's our current template design. So we do a sketch 2 on top of sketch 1, so that way it doesn't affect sketch 1. That says 1. Okay, cool. So let's draw bumpers out. The bumpers are simple. What we're going to do is just do it like this. So use those as reference points, right? So now those are all reference points. What we need to do now is set them all to be equal to each other so that we don't have any issues. No, that didn't work. Click and click. Click and click. Okay, so now so let's draw. Okay, so next thing you do is we need to draw coincidental arcs. So let's do an arc from this point to this point. No, we need to do this a little more. Oh no, let's just do an arc. Arcs are the easiest way to do this. So let's set midpoint of here to midpoint of here, and let's set these two to be coincidental. So that should. Okay. That's a bad idea, actually. We're doing this wrong. So let's delete this. Let's delete that. Let's delete that as well. Okay. So let's set these two to be equal to each other. Then we can mirror it in a second. We're only doing the left side, right? Let's verify this is the left side. You know what? We're doing the right side. It'll be fine. It'll be fine. We'll just rename it to right, and it'll be fine. Coming up on the end of April. Sorry, the end of today. So that's going to be an interesting challenge. Okay, we're coming at the end of April, which means this is basically we're coming up on the end of the day, which means we probably should get this done a little bit better. Okay, let's set the dimension properly then. So let's make sure our bumper widths are okay at least. No, so we need to do it by dimensions. So the next one will be 1.2 or 1.6. So let's do 1.6. There should be 3 PLA layers. So it's 1, 2, 3 layer wall. That's a little weak, but it'll be fine. It'll be fine. Nothing we can do about that now. So let's mirror 1, 2, 3. Okay. Let's mirror it over the mirror line. Okay. Let's try our best now to see what happens here. Okay, so let's extrude A, extrude B. Ah, we've got a thing. Before we did our mirror, we need to do a second arc. That's tangent to it. That is also this should be a driven dimension. So let's make that a driven dimension. So in our dimensions parameters, we use something called print width. So this is a little advanced. This is in fact way too advanced. So when you're 3D printing in Cura, the layer width actually does matter, right? So when you set it to 0.2 or 0.4, it does cause changes, right? It does make things different. So in order to make sure that everything is, well, that's not what I wanted. What just happened? Oh. Show all tabs, please. There we go. Thank you. Cool. So in order to make sure that everything kind of works, that's what I wanted. Shit. Okay, so we need to make this a driven dimension. So it should be print with. That's not a dimension. I just parameterized it. I probably named it something stupid. Parameters layer width. It should be print width. Okay, print width is 0.2 millimeters. So what does this mean, right? It's 4. Okay, so what does that dimension mean? That is wrong, so that leads to an error. So we can see that error real quick, so let's fix that. Dimension from here to here should be this. Okay, so what does that value mean? Why is that here? Okay, so if we've got enough RAM to, we barely do. Let's open up Cura. Hello, Bushelio, how are you doing? Let me see if I can wave at you. I don't have waves set up. Avatar is good. Why can't I do a thing? General settings. Huh, I can't do a pose. Why can't I do posing? Avatar is correct. Props. I don't have any props. Mirror motion. Okay. Why is it doing that? Okay. I don't have any. I can't do any poses. Ah. Oh god, what did I use to do poses before this? I know you are. I kind of figured that. So, well, how are you doing? I hope you're enjoying the stream. So look, here's the wall thickness. So that is a driven dimension. So if I grab a random file, let's grab a random file, like a warship. Right? Let's grab a certain file. That's a nice ship, and let's slice it. So when we slice it in the interior, right, we can see this, which is the amount of walls, right? The wall thickness is given as 0.8, and then the wall line count is given as well as 2 for 2. So that is a good point of reference. So that means my dimensions are wrong. Why is my wall thickness so thick if my settings are 0.2? Line width is 0.4. Okay, so the width of a single line. Oh, okay, so the width of the line is 0.4. Cool. So that means that most of my dimensions are going to be So this is too low. So inspect, tools, manage, view. Where is it? Oh, I'm not in the file. Right, so let's go to tools, inspect. Where? Oh my god. See, this is why I want it to be that. So it's going to be. So this should be wall thick, right? No, so print width is still fine. It should be 0.4. Okay. So that means we should probably add a numeric, which is wall width, and wall width is just print width times 2. Okay, so that gives us that. So this should be wall width times 2, and that gives the same dimension. Okay, so that's good. So that's what we want now. We're now in a good position. Thank you, Francesco. I hope you enjoy. I know Mike is gonna love this, but I hope you enjoy this. Considering that I've got about 20 minutes left before the stream sort of ends, and I go back to being a regular fleshy person. So let's mirror it over the position. Mirror it over line. Apply. Done. Let's extrude on target. So we should be good now. Let's hope this works. A, B, C, D, E, F. Oh, that's not good. That's not what we wanted. Okay, that's not good. That's in fact not what we wanted. Okay, so there's a lot more needs to go on with these bumpers than we initially anticipated. So let's start with those first. First, we need to be able to have a wall from here to here. Connect to the bump to the surface of this. Yeah, okay, that gives us that at least. So let's make this 2 parallel. Let's create dimension between the two, which is equal to wall. No, it should just be equal to fx 1.6. Okay, good. So that equals to that. We should do the same for here, so that there's at least something we can use to connect it to point from point A to point B. Maybe we could do a single piece. Let's do a single piece. It'll make things a little bit easier. Will it? Will it? Yeah, fuck it, it will. Alright, so let's make it a single piece. So let's set 1.6, good. Alright, so that means that and that, and then good position, and that are in good position, and that are in good position. This leads to an issue, so let's fix that by doing a 1 and a 2 and a 3. So that should... Okay, so this and this should align perfect, so that makes it a lot easier. Okay, cool, so that means this is now a one-piece bumper, which wasn't what we were going for, but good enough. Deke, let's see what we can do here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, we've got to mirror that piece. Let's fix that right now. Let's fix that right now. So, okay, but let's go back to the sketch real quick so we can fix that. We should mirror this line, and this is a bad spot actually. Actually, it's in a decent spot. Okay. So we did not mirror this and this. So let's mirror those 1, 2, and then 3. Mirror. Okay. Right. 1, 2, 3, 4. That gives us a good enough start. I like the design so far. It's looking pretty decent. It's looking like all my other designs, but I guess that's pretty decent. I hope you're enjoying the stream right now, because it's almost... I'm going to have to end it very quickly, because I need to go get something to eat and then start working on actual work. But I think now I think we now do the last section of this bumper. Let's try this. This is not going to work, but let's try it. Because I just know this is not going to work, but we're going to try it anyway. So, point A, point B. Does that align properly? Good, okay, so let's... Let's see if this works. Alright, let's continue. Let's edit the sketch. Oh god, this is not gonna work. This is not gonna work. Okay. I don't think that's gonna work. Let's try it though. Moves out of the way. I'll be damned, it just might work. So let's make sure everything works first. Why is it conflicting? Why is there conflict? That's not what I wanted. Okay, so let's constrain A to B. Oh, that's why. Cancel. Why is it not doing that? What the hell is going on here? Why is it doing that? What? That can't be good. That means something is wrong. That means something's wrong. Why is something wrong? Nothing should be wrong. Save everything real quick. Nothing should be wrong. Something is wrong. Something is broken. Something is broken, and that is not a good. That is not a good. So let's try. Okay, so what's breaking? So what's breaking? Show sick. Why is that breaking? What? So why is it doing that? So delete. Why did that break? There were two mates the same motor mount? What the fuck? Anyway, seems like nothing is broken now. That's what we call a good. Okay, so that means that's good. So let's do this. Good. So now let's do with this. Nice. That's actually surprisingly a decent idea. Oh, I've got a stupid idea here. We can mount, instead of mounting the camera to a chassis frame, why don't we do that? That makes things much simpler. That makes things much simpler. Because now, we don't have to do any crazy... Let's do that. So, instead of mounting the camera to something else, it gives us actually more dimension space. So let's fix that real quick. So let's go to the original diagram, and let's bring this back down to 20. Let's see if that fixes everything. Everything should update except this mate broke. That's fine, we kind of expected it to. Okay. No, should be sisters. What's going wrong here? Show sick. It's only that mate. Why is that? It should be sister mates. Why is it not? Uh oh. Huh. I see what happened. Here we go. So they're not self-referencing. Okay, that's what we call a bad. That's what we call not supposed to do that. That's in fact not what we wanted it to do. Oh, okay, so they're not self-referencing. Why is that? Okay, now the mates aligned, everything should work. That's not good. They're not self-referencing each other. So I have made a mistake in CAD somewhere. Yes, I have made a mistake somewhere because these are supposed to be self-referencing and they're not self-referencing. Oh! No, wait, hang on. Can you self-reference sketches? Probably not. Okay, so that means that there's a problem, and we're gonna deal with that problem in a bit. Reference across multiple files. Invented. Alright. Okay. Well, that should be fine. We're just gonna have to make sure that everything is updated properly until we have a general idea of how we can fix this. So, make sure everything fits at least. Oh shit! That's not good. Okay, so that is in fact the bad idea. Okay, so let's leave it alone then. Okay, now everything sort of works. Now everything's back to normal. Cool. Okay. Yeah, so we can still do it. It's just going to be still spaced weirdly. Okay, so let's do that then. So let's draw a second sketch so that we don't interfere with the first one. We need a box 19 mil across. Perfectly aligned, and then sort of back it up a little bit like this, as far back as we can get it. Okay, so let's make this and this parallel. So no, that's not what we wanted. Parallel constraint, parallel A and B. Cool. So now there we know the parallel. Let's lock on target here. On target here. Okay. So now we need to align this point with this point. Cool. Interesting. Very interesting. Okay, so I see a small point here. That's okay. So that's interesting, but we have no choice. So let's keep going with this. Apply, and let's get this section done here. Extrude it out, extrude it downwards, extrude it as a fill, and then make sure that's the same dimension. So let's go to apply, okay. Now this is going to be landing on bottom, right? So this is going to be in the bottom side. So we need to make sure the camera doesn't hit it. Okay, so that means we have to design the slot like that, sort of. That's good actually, it gives us more battery space to work with, I think. Yeah, it does. Okay, I think we're doing good. I think we're doing good so far. Okay. So let's attach the camera, and then once the camera's attached, we should be done. So let's start by doing a sketch. No, I don't want to do it that way. Let's do it this way. Yes, I see the little hole there. We're gonna make that hole bigger actually, just so that we've got a good optimization on our quarters. 0, 0, 2.A. Let's do something called optically guess it, which is a good thing to do. That is very high actually. That is way too high. Alright, so let's look at it from front view. So that would be minimum. Oh, that's much better. Okay, cool. So let's go back to that sketch, please. Okay. Oh wow. Hang on. No, that's not. We can't use that. We can't guess that. It's a function of the bottom. You know what? It's a function of the bottom. So let's figure out how we can function it mathematically. We know the camera's minimum from top to bottom is 19.25. So let's say 20, because we've got a little bit of reference. So that means that from the sketch here, from the bottom side, let's look at this so we can get some view. So that means from the bottom of this wall, right, it must be 20 divided by 2, so 10 up. Okay. So I want to make sure that's not attached to that piece. Okay, cool. So what if let's see what we can do if we shrink the frame just a little bit. Just to see if everything breaks, right? So let's see if this breaks. Let's shrink it to 8 mil. Actually, how thick is it on the reel? Because it's very thin on the reel. Let's grab this. Okay, so on the reel, let's grab a caliper real quick. We're almost coming up on time, so I'm going to end the stream in a little bit, but let's at least get this working. So, on the reel, the propeller is really only about 5 mil, right? So let's say 6 mil to let's say 7 mil to cover everything. So with 7 mil, right, that gives us a lot more extra weight reduction. So let's check that extrusion, see if everything breaks. 7. Does anything break? Yet? Nothing broke. Okay, cool. So this is gonna be annoying. So let's make sure that that's a perpendicular constraint from ground. Oh, it did connect. It did connect. Delete that constraint. Cool. So now let's do perpendicular constraint from A to B. Okay. Okay, so now if we make it like 6.5, which let's try it at 6.5, because that's kind of what we pulled from the sketch. Cool, that still gives us a lot of wiggle room to work with. Cool. Cool. Nice. Alright, so now everything is sort of in play. We don't need it to be a big square actually, so let's get rid of that big square. Okay, that's a good dimension in my head, so let's dimension that real quick and then let's be done. So that's 8 millimeters back, good. That's an actual decent, wow, we've actually got solid numbers for once. So, wheel of 2.25, I think is the, yeah, that's correct. So that's an M2 screw dimension. Yeah, so that's an M2, yeah, that's M2. So let's parameterize that, just so that we've got it. So that gives us M2 screw plus tall. We should probably add a tall. Let's add tolerance just to make sure things we've got it. Okay. That's too far forward. Yeah, that'll be too far forward. That'll be too far forward. Yeah, let's just make it no, it'll be safer. We're almost done, I swear. I'm gonna end the stream in like a second. This is what happens when you start CADing, is you're like, I wanna end the stream, and then it, you know, the stream goes for like 7 hours. That's not what we wanted. Did it link to something? Oh, that's actually perfect. Alright, so hang on a sec, everybody. Okay. So let's extrude the piece out. I think that's good. Yeah, so let's fill in that. See if that helps with the print a little bit. Fill it a lot less than that. I guess we set that to print with. Oh, it gets away with that perfectly. Apply. Cool. So now let's mirror these two. So let's mirror extrusion 2 and fill it 1. Mirror. Yep. And now let's really quickly constrain our this to our this. Constrain this to the wall surface here. And would you look at that? So let's really quickly just rename this to bumper all. Would you look at that as I look and breathe? Grounded. And camera angles are good. Nice. Nice. Okay, this is a good spot to save it for the day and end it. So let's see everything. Alright. So, that is the end of this stream. I might go back to streaming this more later if I'm not lazy, which is a big possibility. But, thank you everyone for coming to this really weird, event. I hope you guys appreciate the novelty. 30 minutes, so happy April Fool's Day. And, yeah, we will